Hopefully at this point you do already know how to code, because this course is not going to teach you how to program if you've never done it before. If you've learned to code, chances are you've learned what we would call a high-level language. High-level meaning further away from the actual machine code that runs the device on which you're programming. These are languages like Python, Java, C#. They have lots of really fancy features, and you can run them on lots of different devices, but they don't really pay very close attention to the actual hardware of the devices they run on. Then you have things like low-level languages, meaning they sit very, very close to the hardware. These are so specific to the device that, in fact, they are different languages based on which actual physical thing you're writing the program for. These are things like assembly or machine code that directly affect the memory and what executions these machines make. In fact, high-level and low-level aren't really categories, they're sort of a spectrum. How far away from the computer do they actually sit? Well, if you can think of this as a continuous spectrum, the C programming language sits right here in the middle, straddling both, meaning it has a lot of high-level as well as low-level properties. C programming language was developed at Bell Labs between 1969 and 1973 by Dennis Ritchie. It was created originally to rewrite the Unix operating system. So it had to be very close to the hardware, but a lot of people were going to use it for a lot of different devices, and that is what caused it to be one of the most popular programming languages still in use today. C has both low-level and high-level properties. For example, you can directly manipulate the memory from the C code. This lets you be very specific about what sort of memory you partition and when to give it up. So if you're working on a small embedded device that has really limited memory, you know exactly when you're freeing up space, as opposed to a high-level language like Java where you would be waiting around at some point for the garbage collector to come through and clear up space, which, if you have a large device like a mobile phone or a laptop, doesn't make that much of a difference. It also is really efficient at mapping the C instructions to machine instructions. Meaning, when you compile the C language, what you get out the other end and then give to the computer runs really efficiently, which is again why it makes it such a good choice for these small embedded devices, because you don't really have a lot of processing power or space to spare. However, C also is a general purpose language, which is one of the best features of a high-level language. This means that you can write a C program and run it on lots of different options, which is going to save you a lot of time and going to be an incredibly useful skill going forward in your career. C also provides you the option to create logical groupings of data in what we would call structs. This lets you organize your code in a specific way that's going to help you create large programs that are easily manageable. So even though you have all of the power of being able to manipulate memory, you also have the option for well-organized code. These are things that have made the C programming language not only currently popular, but popular for decades. And in fact, every modern programming language is based on C. So learning to program in C is not only going to help you in embedded scenarios, but help you better understand how computers work and how they understand code. And frankly, it's sort of just a rite of passage for all software engineers. So we're going to teach you a little bit of how to program in C in this course, but I encourage you to continue your C education and learn all about the history of programming and what you can do with this incredible language.